Good day, algebra students. We are working on section 5.1, which is on addition and subtraction of polynomials. So where we want to start is, what is a polynomial? So we want to make a definition of a polynomial. So let's do that right now. First off, a polynomial is an algebraic expression. All right. And as an algebraic expression, it needs to be a sum or difference of terms in the form ax to the n, where a is a real number and n is an integer. And not just an integer, a positive integer. And so we could have things that look like this. We could say, 2x squared, or you could have 3x minus 4, or you could have negative 5x cubed plus 3x squared minus 2x plus 8. These are all examples of polynomials. There are some in difference of terms, and the terms are in the form ax to the n, where the power is a positive integer or 0. Can't say that because like 4 here is 4x to the 0 power. X to the 0 is 1, so we just write 4. And that's the way it is for all constants. And then all the others have coefficients and so forth. So we name all these parts. So let me name that. I've said a couple of names, so let's name these parts really quickly. For instance, the numbers that you see multiplied times the variable portions, those are called coefficients. Okay, so in other words, the negative 5, the 3, the negative 2, the 8, those are called coefficients. The 8 specifically is called the constant term. All right, the negative 5x cubed, because it's the term with the highest exponent, is called the leading term. All right. The 3, 2, 1, those are called exponents. Okay? Those are kind of the parts of a polynomial. Now, we say a polynomial is in standard form when it looks like this. Ax to the n, let's go a sub 1 x to the n plus a sub 2 x to the n minus 1 plus a sub 3 x to the n minus 2 plus dot 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 all the way until we get to a sub n. So the a sub 1, a sub 2, a sub 3, this is just a way to list the coefficients. You know, the first coefficient, the second coefficient, the third coefficient, and they're real numbers. A sub n, of course, is the constant coefficient or the constant term. All right. And then the n minus 1, those are the exponents. For instance, this would be 3, then this would be 2, this would be 1. All right, etc. if you let n equal 3. All right, so n just allows us to pick any number for the powers to start them. Okay? Now, let's see. One more thing, the degree of a polynomial is the highest exponent. So if we have like 15 with no variable term, the degree of a constant polynomial is 0. All right? Well, if I have 3x minus 4, the degree of this term, of this polynomial, is 1. That's the highest exponent in the polynomial. If I had 3x squared minus 4x plus 2, then the highest exponent in this is 2, so the degree would be 2, and etc. and so forth. So what we would like to do is add polynomials. So suppose I have 4x squared minus 6x plus 12, and I'm adding that to the polynomial x squared plus 3x plus 1. How do you suppose you would do it? Why don't you give it a try, come up with an answer, and then check back. Ready, set, go. Okay, we're back. How'd you do? How do we add this up? Well, what we do is we collect like terms. In general, this is a collect like terms problem. Now, how do we define the terms? Like terms are going to be terms that have exactly the same variable parts. Now, let me show you where this comes from. Let's go back to regular arithmetic. Suppose we have like 342 plus 131. Okay? Now, how would we add these together? Well, if you remember all the way back to elementary school, you would basically add the 300 and the 100. You would add the 40 and the 30. And you would add the 2 and the 1. Now, why would we do that? Well, now let me go to another method. What if you added this way, 342 and 131? If you added like this, you would add the same column because they were the same place value. All right? So 2 plus 1, those are 1s, so we would add those together. 4 plus 3, that's 4 tens and 3 tens, so we have 7 tens. And 300s and 100 gives us 400s. And so in the same way here, we get 400 plus 7 tens, 70, plus 3 ones, 3, and we get the same answer, 473. So this is common knowledge about addition, is that addition is really adding single digits but keeping track of the place value. That's what collecting like terms is. It's really place values. And if you imagine the x being the place value, x is the place value, then x squared is different. X squared is different than x. They're different, right? Because x squared is x times x, and x cubed is different than x squared, because this is x times x times x, and this one is x times x. And so they're different place values, just like the ones, the tens, the hundreds, and the thousands are different place values. So when we add these together, when we add this problem together, we're going to add the place values together that are the same. 4x squared plus x squared plus negative 6x plus 3x plus 2 plus 1. Now they're like terms, or the same place value rather, where x is some number that represents the place value. And in this case, we would get 5 x squared plus negative or minus 3x plus 3. All right. Now, by the way, just so you know, if I let x equal 10, this becomes 400 minus 60 plus 2, which is 342. And this one becomes 100 plus 30 plus 1, which is 131. And if I add 342 plus 131, I get 473. All right? If I'm letting x be 10. But down here, if I let x be 10, I get 500 minus 30 plus 3, which is also 473. So as you see, algebra is just arithmetic in disguise. And so it works the same way. Like terms are like a place value. And so we never add x's and x squareds together, or x's and x cubes, or x squareds and x to the fourth. We never add those together because it's like they're a different place value. And so we only just add place values together. So let's do a couple of quick problems. Subtraction's really the same thing, except you want to add the opposite. And I'll show you that in just a sec. So here's an example. We want to add these three polynomials. Well, one of the things you can do is you can line them up like place values, where the y squareds are lined up, the y's are lined up, and the constants are lined up, and then you can add those. So 6 minus 2 is 4, minus 5 is a negative 1. 11y plus 11y is 22y. And 7y squared plus 4y squared plus 4y squared is 15y squared. And so therefore, that would be the sum of those. Now, what if we want to do subtraction? What if we had 7y squared plus 11y plus 6, and we want to subtract, say, 4y squared minus 5? So, if we have one polynomial subtract another, then what we can do is we can use the distributive property to take this negative sign, which is now negative 1, times each of these, and rewrite them as negative 4y squared plus 5, like that. And now just collect like terms. 7y squared minus 4y squared is 3y squared. 11y doesn't have another like term. And then 6 plus 5 is 11. And so this would be the finish of the subtraction problem. So what are we doing when we multiply by that negative 1? We're basically adding the opposite. Change subtraction to addition. Change the signs of what you're subtracting to the opposite sign, negative 4y squared plus 5, and we've now added the opposite. And so that's what we're doing in order to do subtraction. Okay? So that is how we do addition and subtraction of polynomials. Now, there's one other thing in this chapter they want you to do they give you something like this, y equals x squared plus 2, and they want you to graph it. And so to graph these, we're going to start off by making a table to graph a polynomial. And we're going to pick values for x, like the y-intercept. X is 0, which gives us y is 2. 0 squared plus 2 is 2. But we can pick x equals 1, and then we get 1 squared plus 2 is 1 plus 2, or 3. We could pick x equals negative 1, so that'll be a negative 1 squared plus 2, which is still 1 plus 2, or 3. And we could go ahead and find some more points. Now, typically, they ask you to find 5 to 7. So if we plug 2 in, we'd get 6. Negative 2, we'd get 6. And so the graph of this would look like 1, 3, or excuse me, 0, 2, 1, 3, negative 1, 3, 2, 6, negative 2, 6, and you would get a curve that looks something like that. And so you want to try and do this and find 5 to 7 points, or ordered pairs. And then graph. And you're really looking for both sides like this. Okay? Any questions? That's it. That's kind of the goal this time. All right? Adding and subtracting polynomials, and then a little bit of graphing. That's all I got for you. Thanks a lot. I'll start making the next video in a little bit. Bye.